Hello students, it's Mr. Maruti, your physics teacher, and this is the second video on chapter electricity. Now we will study about electric potential. So to understand this concept, that is what is the basic meaning of electric potential, we have to assume plus 1 coulomb charge at infinity. So what we have done now, that we have assumed plus 1 coulomb charge which is placed at infinity, and suppose we want to move this charge from infinity to a point, say A. Means we have to move this plus 1 coulomb charge from infinity to this point. So if we want to move this charge from infinity to this point, we have to do some work. Exactly, we have to do some work. This electric potential is the same thing, that is amount of work done in moving this unit positive charge from infinity to this point. That is, electric potential at a point is nothing but the amount of work done in bringing a unit positive charge from infinity to that point. So V is equal to W by Q we have. That is, V stands for electric potential, W for work done to move this charge. Q is electric charge. The SI unit of this electric potential is volt, or we can say that joule per coulomb. Joule for this work and coulomb for this charge. So joule per coulomb or volt is the SI unit of electric potential. So what we have studied now, the electric potential. And what is the definition of electric potential? Electric potential at a point is the amount of work done to move a unit positive charge from infinity to the point concerned, or simply we can say that work done per unit charge in a very simple way. Now there is a term potential difference. Potential difference, or we can say that electric potential difference. So to understand the concept of potential difference, we have to assume 2 points, point A and B, and this potential difference, which is also denoted by V, is given as same as given in terms of electric potential, that is V equal to W by Q. But in this case the definition is something else. Here the electric potential difference between these 2 points is the amount of work done to move a unit positive charge from one point to another, not from infinity to the point. Again I am going to repeat it. Potential difference between 2 points is the amount of work done in bringing a unit positive charge from one point to another point. So we can see that here V is equal to W by Q, and now we will study the numerical based on this concept. calculate the amount of work done to move 5 coulomb of charge from infinity to a point where the electric potential is 20 volt. So what we have to do is that we have to calculate the amount of work done to move 5 coulomb of charge from infinity to a point where the electric potential is 20 volt. Means in this question we have been given the value for charge as 5 coulomb and the value of electric potential as 20 volt, and we have to find out work done. So we know that V is equal to W by Q, the same formula, either a potential difference or electric potential, both have the same meaning here in terms of numerical. So V equal to W by Q can be written as W is equal to VQ. Here this is V is equal to W by Q, so we can write W is equal to VQ. This W is to be calculated. In place of V, we are here to write 20 volt, and in place of this Q we have to write 5 coulomb. So 20 multiplied by 5 is nothing but 100. Since the SI unit of work is joule, so the answer is 100 joule. That is, we have to do 100 joule of work in moving 5 coulomb of charge from infinity to a point where the electric potential is 20 volt.